Optical illusions are all around us, whether they're mirages caused by hot weather or elusive sloped roads that appear to be level. They are everywhere.
They can be mind-bending, but believe it or not, there's one that astronomers use every day to learn about the universe. Everyone knows what a rainbow is. And besides leprechauns, pots of gold, and pride flags, rainbows represent some really cool light physics. Rainbows come in many forms. Besides your classic rainbow that's caused by, well, rain, you've also got sundogs and double rainbows. So how are they all made? Well, it all has to do with how light bends when it passes through water.
Different wavelengths of light travel at different speeds when they pass through materials like water or glass. While this difference in speed is tiny, it is just enough to make the white light from our sun separate into the visible spectrum we see in a rainbow. Red, orange, yellow, green, blue, indigo, and violet. And the shorter the wavelength, the more the light bends. This works with glass, water, and even ice. That's where sundogs come from, ice crystals in clouds.
But why do we sometimes see double rainbows? Double rainbows are rare and result from some very specific circumstances. Oftentimes, you can see a double rainbow if you're looking into a rainstorm with the sun shining from behind you.
The reason you might see 2 or even 3 rainbows is because the sun's light is not only refracting in the raindrops, but is also being reflected by another part of the rainstorm. This is why, if you look closely, you might notice that the colors are reversed in the second rainbow.
You might be wondering what all of this has to do with astronomy. Astronomers actually take advantage of the way that light bends when it passes through a transparent material in order to observe spectra through telescopes. What makes each spectrum special is that every chemical element has a unique light signature that it emits.
You may be most familiar with the colors of neon or argon lights from signs, but when observed with a spectroscope, their light splits into different colored bands. This is really useful because it allows scientists to gather light from stars, nebulae, and even exoplanets that are light years away and determine what elements they're made of without having to pack up and visit them on a spaceship. The JWST recently sent us the spectra of WASP-96b, a gas giant exoplanet 1,150 light years away, which indicated that the planet's atmosphere contains water vapor. In another planet's atmosphere, WASP-39b, scientists recently identified a whole host of atoms and molecules. There's no way we could make these discoveries with just an optical telescope, but with a spectrograph, we can.
And the best part of all this? You can make your very own spectrograph at home and use it to observe the spectra of different things around you. I'm going to show you how.
Hi, past self. Alright, let's get started with supplies. You'll need an empty paper towel roll, a craft knife, or scissors, or both. Both might be good. Some tape. It doesn't have to be gorilla style, any will do. A good pen, a piece of cardboard or cardstock, and a copy of Snow Buddies. Well, I guess it doesn't have to be Snow Buddies, just any CD or DVD you're willing to, sacrifice. The first step is going to be taking the paper towel roll and drawing a nice little U shape, but make it a little bit more open than a U and have the open part pointing towards the end of the paper towel roll you're closer to. I can just show you. It's supposed to look like this. Then cut along that line with your crafting knife. You can also use scissors for this. It is a little bit harder though. Then on the other side, you can take that crafting knife again and cut out a small rectangle. That'll be what you'll look through. Get out of there. Now grab your piece of cardstock and put your paper towel roll onto the cardstock and trace yourself a little circle. Beautiful, fabulous, amazing, Picasso. Then you can cut that out. For this one, you probably want to use scissors unless you want to run the risk of marking up your table, which we definitely didn't do, by the way. Nope, not here, not us. Now remember when you cut that little rectangle into the paper towel roll? You're gonna do that one more time to this little circle here. Gotta get some light coming in somehow, right? And give that a quick little test run. I see you. On the opposite side of the holes you cut in the paper towel roll, you'll put that little circle, and you're gonna take your tape and tape it right on. And tape it right on. Let's speed this up a little bit. Man, I really wanted to make sure that was secure, huh? This is 800% speed, by the way. Why did this take me so long? Gotta be thorough when you're making your spectrographs. Oh, thank goodness we're done. Okay, so now that it's all taped down, we have a sort of spyglass looking thing, I guess. But it is not a spectrograph until we apply your Snow Buddies. or your sacrificial CD or DVD of choice. Put that in with the label side facing down. Voila! Rainbows everywhere you look. Amazing! Wow!
If it burns or emits light, you can observe its spectrum. Just don't use it to look at the sun. Enjoy your rainbows!